For our discussion so far, I keep using the word substance. A mixture is a physical blend of substances. A chemical change is when substances come together and irreversibly react. What is a substance? When I say that something is a substance, what I'm really saying is that it's an element or a compound. An element is the simplest form of matter that has a unique set of properties. When you think of an element, you might think of the periodic table, and you're correct. The periodic table is a visual representation of the elements we can work with. An example is oxygen. You can't break oxygen down into any smaller components. Oxygen is oxygen. I want to show you some examples of elements around us that we use just as is. One example is aluminum. So this is aluminum foil. Y'all have probably worked with this before. I can tear it. This is a physical change. At the end of the day, it's still aluminum. Let's look at some zinc. This is a strip of zinc metal. It's not as lustery, it's a little dull looking, but it is malleable. I can bend it. Another physical property. I can look at iron. So iron also does not have as much luster, but I can still bend it. It is malleable. And then, my favorite one, nickel. Look how shiny this is. So beautiful. So beautiful. It's also very thick. I can't bend it. So all of these are examples of elements. I cannot break these down into smaller components. For example, this strip of nickel has a set of physical and chemical properties. It has a certain melting point, it has certain characteristics, it is nickel. Let's look at something that is a compound, and you may have not known it. Salt. So salt is actually a compound. It is not an element. It's made of two elements coming together chemically to create a compound. Let's talk a little more about distinguishing elements and compounds. Come on, let's go.
At this point, you might be wondering, why do we care so much about classifying, different types of mixtures and physical blends and chemical blends of substances? And the answer is that all of these substances have unique sets of properties. When they come together, they can actually create substances with totally different properties. And by understanding this information, we can better utilize these materials in the world around us. Let's look at an example. So again, why do we care about classifying all of this? Think of table salt. So, you might have a salt shaker on your kitchen table. Table salt is actually composed of two elements, sodium and chlorine. Together, when sodium and chlorine make table salt, we can consume this, right? We can put salt on our food, we can eat it, we'll be fine within moderation. These elements alone, though, are not safe to consume. Let's look at sodium. Pure sodium is a chunk of solid metal, and it actually reacts in oxygen in the air or in water pretty violently. This is not edible. We cannot eat this. We do not really want to interact with pure sodium. If we think of chlorine, actually chlorine gas rose to infamous prominence in World War II when it was used as a form of chemical warfare, and it's pretty lethal. Chlorine gas can kill you. But when sodium and chlorine come together chemically, they make table salt. And table salt is okay for us to consume. We are now starting to describe the matter around us chemically. And in order to accurately describe the matter we're working with, and also make sure we're using a common form of language amongst ourselves, we're going to look at a couple of guidelines for elements and compounds. We use symbols and formulas to represent elements and compounds, respectively. That means that we use symbols for elements and formulas for compounds. And if you remember, an element is the smallest form of matter with a unique set of properties. For example, we looked at the strip of iron. So at the end of the day, iron is iron. You cannot break it down into any smaller component pieces. We also have oxygen, pure oxygen gas. Again, you can't break down oxygen into a smaller component. We also looked at that silver ring before. So again, silver is silver. You can't chemically break it down into a smaller component. Physically, we could change the shape of the iron or the silver, or we could put the oxygen gas in a different container. But at the end of the day, chemically, they're still the same elements. A compound, by contrast, contains two or more elements that have been chemically combined. For example, we looked at table salt, how it's not just table salt, how it's sodium and chlorine. If you think of vinegar, in your kitchen, vinegar can actually be chemically broken down into smaller components. And we will get into how to do that later and how to tell if something has smaller components. We do this because common terms like water and table salt don't tell us any chemical information. And here is where the periodic table comes into play, because the periodic table is full of elements and their corresponding symbols. So, yay! Here is a periodic table. You will find that if you just Google periodic table, you're going to find a bunch of different variations where the designers have used different colors, maybe different fonts, make it look a little different. But at the end of the day, our modern periodic table is laid out like this. We're not going to get into the nitty-gritty details today. What I want you to notice is that each square has a symbol in it that corresponds to an element. And the periodic table is laid out in a specific format that we will get into later. But again, I just want you to start getting familiar with symbols representing the elements. For example, first let's look at symbols. So here's the periodic table again. Let's think about table salt, sodium and chloride. The chemical symbol for sodium is capital N, lowercase a, and the chemical symbol for chlorine is capital C, lowercase l. NaCl come together to make table salt. I want you to take specific note that the first letter is capitalized, and if it has a second letter, the second letter is not capitalized. This will become very important when you're looking at chemical formulas, because you will know, oh, this is one element versus this is another. Let's look at some compounds. So again, a compound is two or more elements that have come together chemically. Water is actually a compound. This is a molecule of water. It is composed of 2 hydrogen and 1 oxygen atom. That makes 1 molecule of water. Its chemical formula is H2O. H is for hydrogen, subscript 2 for 2 hydrogens, capital O for oxygen, and there's just 1 O, so it's an imaginary subscript of 1. Let's look at another. Table sugar. So, the sugar you use when you're like baking and cooking. Table sugar is called sucrose. But again, that doesn't tell us anything chemically about the structure or anything about the substance. Each block of sugar, so each of these blocks of sugar literally, are actually made up of repeating fundamental units. So each of these units is made of carbon, hydrogen, and oxygen. And they're tetrised together in a very specific way. Specifically, the way they tetris together creates this chemical formula. C for carbon, 12 for 12 of them. H for hydrogen, 22 for 22 hydrogens. O for oxygen, 11 for 11 oxygens. Each little repeating unit that creates the sugar we see is composed of one of these repeating blocks, which is made of that many carbons, that many hydrogens, and that many oxygens. Alrighty, let's go back to our handy dandy matter chart. In the last couple of lessons, we looked at the physical ways we could look at matter, specifically analyzing it at these physical blends as mixtures. Let's look at the flip side. Let's look at when matter cannot be separated by physical means. Oh, do not have enough room there. So again, this means I can't filter it. I can't distill it. I can't use my hands to separate out the individual components. If it cannot be separated out by chemical means, if it cannot be separated by physical means, we are working with a pure substance. So as opposed to a mixture, think of that sand and water example. If we just had water, just water, that's a pure substance. But a pure substance can be broken down further into I'm going to run out of room here. I'm going to write it down here. A compound or an element. So for a pure substance, think of water. Think of if we just have a giant pile of just table salt. Can we break it down further chemically? Can we simplify it chemically? So again, for table salt, it's made of 2 components, sodium and chloride. We technically can simplify that down chemically and say, it's made of sodium and chloride. So if the answer is yes, it's a compound. Example, table salt. We also talked about sucrose. If we cannot simplify it chemically, it is the smallest component possible with that unique set of properties. We cannot break it down into smaller component pieces. That is an element. Examples here include pure iron, pure silver, pure oxygen gas. We also looked at sodium, how it explodes in water. We also looked at chlorine gas. Notice how all of these examples of an element, you've probably heard these in reference to the periodic table, and you'd be correct. Elements are represented on the periodic table with symbols. Now we have the knowledge and the power to start really analyzing the world around us chemically. Physically is still very important, right? Like, how do you separate out, your coffee grounds from your coffee? But when we think about matter as chemists, we're generally thinking more about the chemical side. Let's do a brief recap of what we just learned. We classify substances as elements or compounds. An element is the smallest form of matter with a unique set of properties. Elements are represented on the periodic table with symbols. A compound contains two or more elements that have been chemically combined. In order to separate out the components of a compound, you have to use some form of chemical means. Elements alone can have different properties than when they come together to make a compound. And that's where chemistry gets really cool, because you can combine different things and get totally unexpected results that, can be useful in so many different ways. A lot of our modern technology was actually created as a mistake, as a result of a mistake of chemists putting stuff together. So, chemistry!